the expression for trajectory of a projectile. So we have considered a body projected from point O. Okay. So we have considered initial velocity of that object. Okay. So with the initial velocity of u, it makes an angle theta with the horizontal surface. Okay, with the horizontal surface as shown in the figure, you can see there. Next, the acceleration acting on it is that due to the gravity which is directed vertically downward. Okay, so that acceleration is expressed as vector A is equal to minus g j cap. Okay, so coming to the acceleration with respect to the horizontal. Okay, so with respect to the horizontal, it will be 0. The acceleration with respect to the vertical, it will be minus g. Okay, so with this thing, what we are going to do is we will resolve that u into two components. So one is along the x-axis and one is along the y-axis. So along the x-axis, the component of u comes out to be as u cos theta, and the component of u along the y-axis comes out to be as u sin theta. Okay, so and we have considered a particle p. Okay, so you can see in the figure we have considered the particle p comma x comma y. Okay, p into x comma y, which represents the position of a body at an instant of time. Okay, so x comma y is an coordinate. Okay, so next let us consider that if the vertical distance is y. Okay, you can see in the figure here, y is the vertical distance covered. Okay, if that is the vertical distance traveled by an object in a time interval of t with initial velocity u sin theta and acceleration a subscript y is equal to minus g. So next is nothing but considering the with respect to the horizontal, that is the initial position. Okay, initial position is what? O is a starting point, right? So at that time we are going to take the x and y value as 0. X naught is 0 and y naught is 0. The position with respect to x axis and y axis is taken as 0. So hence you are going to write the distance of the object is nothing but y is equal to u subscript yt plus half a subscript y t square. Okay, which is similar to that of s is equal to ut plus half at square. Okay, so by making use of that itself, we have written here. Okay, so the next is, as you know, that can be written as u subscript y can be replaced by u sin theta. Okay, so that is written as y is equal to u sin theta minus y is equal to u sin theta into t minus half gt square. So that is considered as equation 1. Next, coming to the horizontal surface. Okay, that is horizontal distance x is traveled in a time t with a constant velocity u cos theta. So as you know that x is equal to u cos theta into t, because a subscript x is equal to 0, right? So we say that in the absence of air resistance, the velocity along the horizontal component remains the same. That means that we say that the body moves uh, with a uniform velocity, we say. Okay, with respect to horizontal surface. So hence the acceleration is nothing but what? Acceleration is nothing but rate of change of velocity with time. Since the velocity is not changing with respect to the horizontal surface in the absence of air resistance, so hence the acceleration along the x component, that is along the x-axis, comes out to be 0. So hence the value of x comes out to be as x is equal to u cos theta into t, or else that can be written as t is equal to x divided by u cos theta. On substituting the value of t in equation 1, you are going to get y is equal to u sin theta into x divided by u cos theta minus half into g into x divided by u cos theta whole square. Okay, on simplifying that, you are going to get y is equal to x tan theta minus half into g into x square divided by u square cos square theta. So this equation is similar to that of y is equal to ax plus bx square. Okay, and hence we compare this equation with this. Okay, this is a standard equation. We are going to compare this equation with this. So hence, where the value of a comes out to be as tan theta and the value of b comes out to be as minus d divided by u square cos square theta. So hence the equation 2 represents the trajectory of a project, I mean it represents the equation of a parabola. Okay, so hence the trajectory of a projectile is a parabola. Okay, I think till here we discussed in the last class, right? So before starting with the next continuation of that derivation, that is time of flight maximum height, so please go through the derivation once, because it's a continuation of this derivation itself. So once you have gone through the derivation, so we will just switch on to that time of flight. Okay, just go through once for a few minutes. In case if you have any doubts, you can ask. Okay, fine. Any doubts, students? Do you have any doubts regarding the derivation? Yes, Gahana, what slides you want today? I mean, you have sent the message as will you send the slides today? I didn't get what is that slides. Okay, fine. Notes you'll get. Don't worry. Anyway, we are in the ending of this chapter, right? So I'll get the notes. Okay, fine. So now, starting with time of flight. Okay. So with respect to that trajectory of a projectile. Okay. So we are going to define this time of flight maximum height and horizontal range. So coming to the time of flight, so let us go through that. What is it? So it is defined as, it is the total time for which the objects is in flight, that means which remains in air. Okay, so that means that, as you know, that from the initial point when you throw an object, okay, from there to before it strikes the ground, that duration itself is called as, I mean, where the object remains in air. Okay, so that is called as total time of flight we call. Okay, so where the total time for which the object will be in air, and it is denoted by the letter capital T. So hence the total time of flight consists of two parts. Okay, so the first part is nothing but the time taken by the object to go from the point O to the maximum height h. It is called time of ascent. Okay, so see here in the figure you can see, when you throw an object, okay, so it goes with increasing height. So at some point it reaches the maximum height, after that, so the height keeps on decreasing. Okay, so hence where the object reaches the maximum height, okay, so this is the point where the object has reached the maximum height. So hence the point from point O to till here, okay, from point O to till point H, okay, till H, we are going to consider that one as time of ascent. Okay, so it is called as time of ascent we call. Okay, so the next is the time taken by the object to go from the height height point H to the ground in the level of point O. Okay, so that is nothing but it is from H to here. Okay, before striking the ground. Okay, that is taken as time of descent. Okay, so time of ascent and time of descent gives the time of flight. So it is said that as motion of object from O to H is symmetrical to that of the ground, so hence we can consider that time of ascent is equal to time of descent, which is considered as small t, which is equal to small t. So next, as total time of flight is equal to time of ascent plus time of descent, you can write that one as capital T is equal to small t plus small t, that is time of ascent plus time of descent, which is nothing but equal to 2 small t, or else that can be written as small t is equal to capital T divided by 2. Okay, so next, at the highest point h, the vertical component of velocity of the object becomes 0. As you know that when you throw an object, when it reaches the maximum height, at that point the velocity will be nothing but equal to 0. Velocity of an object is 0, right? So taking the vertical taking the vertical upward motion of the object from O to H, we have u subscript y is equal to u sine theta, and a subscript y is equal to minus g, and small t is equal to capital T divided by 2, and v subscript y is equal to 0. Okay, v subscript y is nothing but where the velocity of an object at a maximum height, so that is 0, so hence we are taken as 0. So with these things you can write an equation, that is v is equal to u plus at, which we have come across in the last chapter. V is equal to u plus at, right? In a similar way itself this has been written. So v subscript y is equal to u subscript y plus a subscript y t. Okay, so since you know that v subscript y is equal to 0, and the left out thing is, since you know that u subscript y is nothing but what, it is u sine theta, right? So we have substituted that, and the value of a subscript y comes out to be as minus g, and the value of t comes out to be as t divided by 2. So hence you can write that one as capital T is equal to 2u sine theta divided by g, and this is the expression for the time of flight. Okay, so go through once, go through everything, that is time of flight. So from here to here. So in case if you have any doubts, you can let me. Any doubts, students? Do you have any doubts? Any doubts, students? In case if you have any doubts, you can ask. Okay, fine. Hope that you have understood that time of flight. We will move to the next, maximum height. Okay. So how we are going to define the maximum height? It is the maximum vertical height attained by the object above the point of projection during its flight. It is denoted by h. So as you know that in the figure itself you can know the maximum point reached by an object, okay, itself is called as the maximum height. Okay, so the expression for that comes out to be as taking the vertical upward motion of the object from O to H. We have, as you know, that u subscript y is equal to u sine theta, a subscript y is equal to minus g, and y naught comes out to be 0. Okay, and y is equal to capital H. See, y naught is equal to 0. What do you mean by that? Y naught is equal to 0 is nothing but at this point, okay, at the origin, y naught, we say that y naught, okay, that is the displacement along the y axis, is 0, right? Similarly, x naught is also 0, but at this point, at the maximum height, the vertical displacement will be nothing but equal to, that is y is equal to h. Okay, that is the meaning of that. So with that, the value of small t. Okay, so y naught is equal to 0 and y is equal to h. So as you know that small t is equal to t divided by 2, right? So what is the value of a t? T comes out to be as 2u sine theta divided by g. Okay, so hence t divided by 2, right? So 2 and 2 get cancelled out. The left out thing is u sine theta divided by g. Okay, so hence as you know that from the equation you can write that is s is equal to ut plus half at square. So according to that you can write this as y is equal to y naught plus u subscript yt plus half ay a subscript y t square. So hence you know that what is the maximum y is nothing but what? It is the maximum displacement, right? Or the maximum height reached. So hence we are going to replace that y divided no, y by h, and y naught is nothing but what? The value of that is 0. We are substituted, and y subscript I mean u subscript y is nothing but it is u sine theta. Next t value comes out to be as u sine theta divided by g plus half a subscript y is equal to minus g. We have written that, and as usual the value of t is u sine theta divided by g, so whole square. Okay, so simplifying this you are going to get this as h, I mean h value as h is equal to u square by g sine square theta minus half u square sine square theta divided by g, that is nothing but equal to u square sine square theta divided by 2g. Okay, so hence the value of capital H, that is the maximum height expression, comes out to be as h is equal to u square sine square theta divided by 2 theta, I mean 2g. H is equal to u square sine square theta divided by 2g. Okay, so this is regarding the expression for maximum height. Just go through once. In case if you have any doubts you can ask. Okay, fine. Any doubts? In case if you have any doubts, you can ask. Okay, we'll move to the next. That is, yes, Ashrit. Yes, Ashrit, you have doubt? The value of small t. The value of small t is nothing but this itself. It has been given here, Noman. Small t is nothing but equal to what? See here, you can see here, small t is equal to capital T divided by 2, right? That is what we have taken there. Small t is nothing but capital T divided by 2, whereas the value of capital T comes out to be as 2u sine theta divided by g. So since you know that in this case, small t is equal to capital T divided by 2, right? So 2u sine theta divided by g is divided by 2. So 2 and 2 gets cancelled out. The left out thing is u sine theta divided by g. That is what we have taken. The value of t comes out to be as u sine theta divided by g. Is it fine? Okay, fine. So the next is the horizontal range. Okay. So it is defined as the horizontal distance covered by the object between its point of projection and the point of hitting the ground. It is denoted by capital R. You can see in the figure here what is the range. Okay, from point O to till here. Okay, so from here to here it is maximum, I mean horizontal range. Okay, so we need to express in terms of mathematics. As you know that the horizontal range is the horizontal distance covered by the object with uniform velocity u cos theta in the time equal to the total time of flight, right? So r is equal to u cos theta into capital T. Okay, so the horizontal range is expressed as, okay, it is expressed as the horizontal distance covered by the object with uniform velocity u cos theta in the time equal to the total time of flight. So capital R is nothing but equal to what is the uniform velocity along, I mean velocity value along the uh, x-axis, that is u cos theta, into total time of flight is capital T. So hence the capital value, I mean the capital T value is 2u sine theta divided by g, right? So simplifying that, you are going to get u square divided by g into 2 sine theta cos theta. Okay, so in the trigonometry, as you know that 2 sine theta cos theta can be written as sine 2 theta, right? So hence replacing that, you can write the expression for r as capital R is equal to u square sine 2 theta divided by g. So hence this is the equation for horizontal range. Okay, so you can go through. In case if you have any doubts, you can let me. Okay, fine. Any doubts, students? Have you understood all the three? Time of flight, horizontal range, and maximum height? Any doubts you can ask? Okay, fine, students. It's time up. Okay. So the rest of the topics we will discuss in the next class. Okay. Okay, students.